So hey there everyone, welcome back to the channel. Today we are going to discuss this problem 1582 of today's Leetcode POTD, spatial position in a binary matrix. So again, this is of easy category. So let's first of all go through this problem. So given an m cross n binary matrix, by binary matrix they mean that only 1 and 0 are the two elements which will be present in our matrix. That's why binary matrix. And return the number of spatial position in mat. Okay, a position I comma j is called spatial if mat ij is equal to 1 and all other elements in row I and column j are 0. Okay, so there is only one thing in this question. If you are able to understand that simple observation, this problem will become really very easy. So we have to only focus on these two lines. That is, index, or I can say a position I comma j is called spatial if at that point the element value is equal to 1 and all the other elements other than that in that particular row where this element is present and in that particular column also which is associated with this element, all the elements in that row and column must be 0. So what they're trying to say is, let me try to show you. Let's say this is our matrix and this is our some ith row. Okay, this is our matrix ongoing, these are some of our ongoing columns, and let's say this is some arbitrary ith row, and let's say this is some jth column, correct? And in this column what they are trying to say, if we are able to find one pair of this ith column as well as ith row as well as jth column in such a way that element over here, let's say mat of I comma j, this element over here is 1, then in that case for this I comma j to become a spatial, what we have to do is, in this whole column where this element is present, in this whole column all the other elements must be 0 and all the other elements in this particular row must be 0. So this is what they are trying to say. If this is the case, then this position, that is I comma j position, is called as a spatial position, and what you have to return is the number of spatial positions present in this matrix. It means how many such type of positions are there, that you have to return. So I hope you have understood the question. And over here, if you have done one observation, that in order to fulfill this, that to make any I comma j spatial, if this condition is fulfilled, let's say over here I am considering that this ith comma j position is a spatial position, so in that case all the other element which is present in a row associated with that particular number, that is 1, are equal to 0, and all the elements present in that column associated with this value is also 0, right? So what is the sum of all the elements in this row? If I may ask you this question, that what is the sum of all the elements present in the row if this condition is satisfied and this is a spatial position? I'm directly giving you this thing, that I'm considering this as a spatial position. Now tell me, what is the sum of this row in this case? So you will say the sum must have to be 1. Okay, and if I ask you that what will be the sum of the column in this case, so you will say the sum must have to be equal to 1 in this case. Then and then I can say that this is a spatial index, right? So this is a simple observation, that whenever my row sum is equal to 1 and whenever my column sum is equal to 1, then they can be served as my potential row and column, where I can be able to find one position which can be considered as a spatial. Okay, so these are if whenever my sum of any row or column is equal to 1, then they can be considered as my potential rows and column, where I can find some position which can turn out to be spatial. So using this observation, I will be telling you and I will be forming some logic, and after that we will be looking into the code. Now using this same observation, what we are going to do is, we can simply, first of all, we are going to check sum of all the rows, and after that in the similar fashion we are going to check the sum of all the columns. So let's try to do this, and On with this ongoing, we will try to form some logic to code this out, right? So first of all, let us taking this first row, then second, then third in this form, and they have been already mentioned that rows and columns are zero index. So we'll be starting from zeroth row, then first, and then this is second row. This is zeroth column, first column, and second column. So let's try to check the sum for the first row. So the sum for the first row is 1, obviously. Sum for the row number 1 is again 1. Sum for the row number 2 is again 1. Now let's try to check the sum for all the column. So sum for the column 0 is 2. Okay. Sum for the column 1 is 0 and sum for the column 2 is 1. Now as I have told you over here, that in order to find the spatial position, this spatial position can only be occur, and it has potential to occur whenever sum of any row is equal to 1 or sum of any column is equal to 1. If I am able to find sum of any row or column is equal to 1, they can be served as my potential row and column where I can find some position which can be called as spatial, right? So all the rows where my sum is equal to 1, like in the row number 0, in the row number 1, in the row number 2, this all the row indices will serve as the potential row where I can be able to find such position which can become spatial later on, correct? And over here also, from column also, we will filter out the columns wherever sum is equal to 1, which can be served as my potential columns where I can find such position. So over here, there is only one single column where my sum is equal to 1, that is column number 2. And for row, I have 0, 1 and 2 as my potential row. And for column, I got only one column, that is column number 2. And now since we are given that the constraints are very small, that is equal to 500, I guess, you can also check it in the question. So the constraints are very low. So what we can simply do is, whatever are our potential row and column, for each and every potential row, I will try to check with each and every potential column if this condition is satisfied or not, that is mat ij is equal to 1 or not. If this is satisfied, then we will increment our answer, correct? So since the constraints are low, so I first of all I will be checking 0 with 2. So I will be checking at position 0, 2. If it is equal to 1, then I will increment my answer counter. If it is not, then I will move ahead. Even if it is equal to, then also I have to move ahead. I have to check for each and every row indices with each and every column indices. So for now, for the row 1, again I will make a form of pair over here, and I will again check. So for each and every row, I will be trying to check with each and every column. And if in any case I'm getting this condition that my mat of row, mat of ij is equal to 1, then I will increment my answer, and finally we have to return it. So that was it. That was a simple logic. Now we will have a look at the code. Now here is my code. So as per the logic, we are going exactly the same as I have explained you in the logic. So first of all, as I have told you that we will be going to take first of all sum of all the rows, and we will be checking whenever the sum of row is equal to 1, then it can be taken as our potential row where we can find such position which can be spatial. So I will be pushing all such rows where the sum is equal to 1 into my vector, that is row int. And similar thing I will be doing for my columns also. For each and every columns, whenever I will be able, whenever I will find some potential column indices, I will be pushing that into my vector call underscore int, correct? So after doing this, I will declare an initialize answer, which will be storing the count of all the spatial positions present in this matrix, and I will be initializing this with 0. And as I have told you, since the constraints are very small, for each and every row index, I will be going ahead and checking with all the possible column indices. And whenever this condition is true, that is mat ij is equal to 1, then I will increment my answer. And finally, at the end of the day, whatever it is, I will be returning my answer. So that was it. That was the simple code. And let's try to submit it. Okay, so cool. Yeah, that was it. That was the solution. Now, if you have any doubt or query, you can ask me in the comment section, or I will see you in the next one.